If your residential load calculation worksheet is displaying a pole panel riser diagram even when you don't have a pole panel, firstly, make sure that you have selected No to the question, does this calculation include a pole panel? Secondly, check the Details tab to confirm that the pole panel field is indeed set to No. If you are having trouble printing the actual load calculation report, firstly, click on the Print button. Secondly, select Load Calculation Report from the drop-down menu. Thirdly, ensure that your printer is selected and click OK. If these steps do not resolve the problem, contact Electrical Know-How customer support at 1-800-426-1787. They are available Monday through Friday from 800 a.m. to 500 p.m. Pacific Standard Time. It's important to remember that you do not need to purchase the full program to use the free worksheet. There are also alternative calculation options available online. For example, EC&M offers a residential load calculator which can be found at ecmob.com/design/calculators/residential load calculator. Green Building Advisor also provides a home energy calculator accessible at greenbuildingadvisor.com/calculators/home energy calculator. Another option is the Home Power Load Calculator, available at homepower.com/articles/self-reliance/testing load calculator. These alternative calculators may provide different features or interfaces, so explore them to find one that best suits your needs. When performing load calculations, remember that accurately determining the connected load is crucial for electrical system safety and performance. Undersized systems can lead to overloads and potential fire hazards, while oversized systems can be unnecessarily expensive. The National Electrical Code, or NEC, provides guidelines and requirements for load calculations to ensure safe and reliable electrical installations. Understanding the NEC requirements is essential for electrical professionals and anyone involved in electrical system design or installation. Key factors in residential load calculations include general lighting and receptacle loads, appliance loads, heating and cooling loads, and motor loads. General lighting and receptacle loads are typically calculated based on the square footage of the dwelling. The NEC specifies a minimum load of 3 volt-amps per square foot for general lighting and receptacles in dwelling units per NEC section 220.12. This value is then adjusted based on demand factors, which account for the fact that not all loads will be operating simultaneously. Appliance loads include both small appliance branch circuits and individual appliance loads. The NEC requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas per NEC section 210.11. Each of these circuits is calculated at 1500 volt amps for a total of 3000 volt amps. Individual appliance loads, such as ranges, ovens, dryers, and water heaters, are calculated based on their nameplate ratings. Demand factors may also be applied to these loads depending on the number and type of appliances. Heating and cooling loads are calculated based on the heating and cooling equipment installed in a dwelling. The NEC requires that the larger of the heating or cooling load be included in the service calculation per NEC section 220.82. The heating load is typically calculated based on the nameplate rating of the heating equipment, while the cooling load is calculated based on the nameplate rating of the air conditioning equipment. Motor loads include the loads of any motors installed in the dwelling, such as well pumps, septic pumps, and pool pumps. The NEC requires that the largest motor load be calculated at 125% of its nameplate rating, with the remaining motor loads calculated at 100%. Once all of the individual loads have been calculated, they are added together to determine the total connected load. This total connected load is then used to determine the size of the service entrance conductors and overcurrent protection devices. It's important to consult the NEC and local codes for specific requirements and demand factors applicable to your area. The NEC is updated every 3 years, so it's crucial to use the latest edition. Using a load calculation worksheet or software can help simplify the calculation process and ensure accuracy. These tools often incorporate the NEC requirements and demand factors, making it easier to perform complex calculations. However, it's essential to understand the underlying principles of load calculations and verify the results obtained from the software. If you are unsure about any aspect of load calculations, consult with a qualified electrical professional. They can help you determine the correct loads and ensure that your electrical system is safe and compliant with all applicable codes. Furthermore, remember to document your load calculations for future reference and for inspection purposes. This documentation should include all of the individual loads, demand factors, and calculations used to determine the total connected load. Proper documentation can help demonstrate compliance with the NEC and facilitate troubleshooting in the event of any electrical issues. When selecting electrical equipment such as service entrance conductors and overcurrent protection devices, always choose equipment that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertech. This listing ensures that the equipment has been tested and meets applicable safety standards. In addition to the NEC, local codes and regulations may also apply to electrical installations. These local codes may have more stringent requirements than the NEC, so it's important to be aware of and comply with all applicable codes. It is also important to understand voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders according to NEC section 210.19 AON and 215.2 AON. To minimize voltage drop, use conductors of adequate size and minimize the length of the conductors. You can use voltage drop calculators to determine the appropriate conductor size for a given load and distance. Another important consideration is grounding and bonding. Grounding provides a path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of voltage differences and shock hazards. The NEC specifies detailed requirements for grounding and bonding, including the use of grounding electrodes, equipment grounding conductors, and bonding jumpers. Surge protection is also an important consideration, particularly in areas prone to lightning strikes or power surges. Surge protective devices, or SPDs, protect sensitive electronic equipment from damage caused by voltage surges. The NEC requires SPD to be installed in certain locations, such as dwelling units and critical facilities, per NEC section 230.67. Consider installing SPD at the service entrance and at individual equipment locations to provide comprehensive surge protection. Arc fault circuit interrupters, or FSIs, are another important safety device. FSIs detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires FSIs to be installed in branch circuits supplying outlets in dwelling unit bedrooms, living rooms, dining rooms, and other areas per NEC section 210.12. Replace standard circuit breakers with FSIs to provide enhanced fire protection. Ground fault circuit interrupters, or GFCIs, protect against electrical shock hazards. GFCIs detect ground faults, which occur when current leaks to ground. The NEC requires GFCIs to be installed in branch circuits supplying outlets in dwelling unit bathrooms, kitchens, garages, and outdoor areas, per NEC section 210.8. Replace standard outlets with GFCI outlets in these locations to provide enhanced shock protection. When working with electricity, always follow safe work practices. De-energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrical professional. Proper planning and preparation are essential for any electrical project. Before starting a project, obtain all necessary permits and approvals from your local building department. Create a detailed plan that includes the scope of work, materials list, and safety procedures. Following a well-defined plan will help ensure that the project is completed safely and efficiently. Regular maintenance is essential for keeping your electrical system in good working order. Inspect your electrical system periodically for any signs of damage or deterioration, such as cracked or frayed wires, loose connections, or corroded terminals. Replace any damaged or worn components promptly. Consider having your electrical system inspected by a qualified electrical professional every few years to ensure that it is safe and compliant with all applicable codes. When making any changes to your electrical system, always use qualified electrical professionals. Avoid making unauthorized modifications, as these can be dangerous and may violate local codes. Working with qualified professionals ensures that the work is done safely and correctly. By following these guidelines, you can help ensure that your residential electrical system is safe, reliable, and compliant with all applicable codes. Remember that electricity can be dangerous, so always exercise caution and consult with qualified professionals when needed. The electrical system is not something to take for granted. There are dangers such as shock hazard, fire hazard, and other kinds of dangerous results. If you smell something burning, turn off the power from the main breaker and call a qualified professional. The main panel itself is also important to keep free of anything that could catch fire and avoid storing items within 3 feet of the panel.